This is the answer to Chapter 10, problem number 33 from the Smith Organic Chemistry textbook. And this problem says devise a synthesis of each compound from the indicated starting material. So we have two sequences here, A and B. We're given a starting material and we're given a product, and we're asked to get from the starting material to the product. And so basically, in both of these cases, what we're going to do is we're going to do an elimination reaction to get to the alkene. And then when we have the alkene where we want it, we can do some of the different reactions that we learned about in this chapter to get from each of these alkenes to each of these product compounds. Okay, so looking at A is an alkyl bromide. And so to get to the alkene, we're going to need to do an elimination reaction, as I said. And we're going to use potassium tert-butoxide. So there are different ways of writing this, but TBUOK is one way that's pretty common to write potassium tert-butoxide. And so that is going to get us to this terminal alkene. So from here, we need to add an alcohol, and we need to add a chlorine. And so one of the ways that we've learned that we can do this is to do a halohydration. So we can use chlorine gas. And remember, just chlorine gas would give us the dichloride product. But if we get some water in there too, we're going to add an alcohol to the more substituted carbon, and then we'll add a chlorine to the less substituted carbon. And so that's going to get us to the molecule that we're looking for here. So this step will get us to our desired product for A. Okay, and so for B, we're going to follow a very similar sequence. So B starts off as an alcohol. So potassium tert-butoxide is not going to give us the elimination reaction that we want, but we can do an elimination reaction here with concentrated sulfuric acid and some heat. And when we add acid to this and heat it up, what we get is the alkene. Okay, so now we have an alkene right where we need it, and we need to add a hydrogen and an alcohol. So we need to add the elements of water across this double bond, and we need to add them in such a fashion that the OH is added to the less substituted carbon. So if we were to use sulfuric acid and water and just do a hydration, the alcohol would add to the more substituted carbon, and we would just get our starting material back. So what we need to do is select the complementary set of reagents to get addition at the less substituted carbon. And as we learned in this chapter, that's going to be a hydroboration oxidation. So BH3 followed by hydrogen peroxide and some base is going to get us to our product molecule here. Okay, and so that's the answer to this problem. It's a pretty good little introductory to synthesis type problem. And this is a good way to start thinking about how to get from what you have to what you want using reactions that you've learned. And since this is the alkenes chapter, both of these reactions are going to go through an alkene intermediate and then make use of some reactions that we've learned. And that's the answer to chapter 10, problem number 33.